Okay, so in this problem, we're going to review the ALEX objective, writing net ionic equations. And so a net ionic equation is one where we have eliminated all of the spectator ions. And there's a couple of ways of doing this. I'm going to show you the most thorough way that will work in 100% of cases. And then I'm going to show you a little shortcut that can sometimes be useful for double checking your work. So the first thing to recognize is that any aqueous ionic compound will always dissociate into ions. And so that'll be a cation, just the one, and an anion, because we're only dealing with what we call binary ionic compounds where there's one cation present and one anion present. Now, how you know the charge on the cations and the anions is by either the position on the periodic table or by consulting a table of charges and formulas and names for polyatomic ions. Now, when I look through here, I can see that all of the anions, all of the ones that come second in the formula, are polyatomic. And I'm going to want to look up their names, formulas, and charges in a table. So the first anion that I've got there is NO3-, which is the nitrate anion. And then the second one that I've got is the hydroxide ion, OH-. So I want to be certain of those, the formulas and the charges for those guys. So when these ionic compounds dissociate into their ions, the non-metal atoms that are within the polyatomic ions don't separate from one another. So I'll show you what I mean. So magnesium nitrate there, magnesium's in group 2A, so we're going to figure out its charge from the periodic table, so it's just going to become Mg2+, and then I've got 2 of the nitrate anions. You see how I'm doing that? So that's dissociating that guy. Now I've got 2 of everything that comes next. So I'm going to have 2 sodium ions, and I know that its sodium is +1 because it's in group 1A. And then I've also got 2 hydroxide ions. So that's everything in the reactants has been dissociated. So now this is going to go ahead and form my products. Now, when I have an ionic compound that's a solid, you don't dissociate that because the ions are locked in place in a crystal. They're not acting as individual ions. So the MgOH2, because it's got the solid label, is not dissociated. And then now I just have to dissociate the aqueous ionic compound that's in the products. So I'm going to get 2 Na pluses AQ. Because sodium's in group 1A, it forms a single plus cation. And then I also get 2 nitrates AQ. And I knew the formula and the name of that and the charge because I'd looked it up in a table of polyatomic ions. So to get my net ionic equation, just to focus in on the things that are actually reacting, I'm going to remove all of those things that are not changing in any way. So I'm going to cancel out what we call the spectator ions, and they're the ions that appear in the products and reactants in exactly the same form. And in this case, that's going to be these 2 sodium ions and then these 2 nitrate anions. And then what I'm left with is my net ionic equation. So what I did was I went to the complete ionic equation or the total ionic equation and then eliminated spectator ions in order to get the net ionic equation. And so the net ionic equation is Mg2+ AQ plus 2 OH minus AQ gives me MgOH2 solid. And there we are. So I promised that I would show you a little shortcut for doing this. And what you're going to do is, instead of writing the overall ionic equation or the total ionic equation and then eliminating spectator ions, you're going to begin with the solid product. So you look at this and you go, aha, this is a precipitation reaction. 2 ionic compounds, ionic compound 1 there, and ionic compound 2 are reacting to form two new ionic compounds, and one of them is a solid. And when I see that, I can apply this shortcut sometimes if I know what I'm doing. What I'm going to do is I'm going to begin with the precipitate, with the solid. And then I'm going to work backwards and say, what ions is it made from? Well, it's made from magnesium ions, and because magnesium is in group 2A, they're 2+. And it's also made from hydroxide ions, and there's 2 of those, and they are OH-. So that's going to go in there, plus 2 OH- AQ, and you can see it leads to the same result. So if you can recognize this as being a precipitation reaction, then you can do that. Start with the solid and work backwards, and it'll give you the answer that you want. Okay, hope you found the video helpful. Good luck with everything.